Recording is started. Regarding the news, as I said, I only have one news because the others I was not able to put it on the slides. I came across, I think last week or the week before last week, across an article which was published at decoder.com, where this was an article about a study which the US Copyright Office made and published in the overall context of fair use and AI training and so on, because most of the persons say, oh, we train our AI models with copyrighted content, but we regard this as a fair use of this copyrighted content. And this overall study or paper is more than 113 pages long. So I did not read it because I had not the time. But the article said, this general argument that this is fair use cannot be held up in all cases, because when you have trained an AI model with copyrighted content, the AI model can also, without any efforts, regenerate derivative works, and so on and so on, and thus it will endanger the business of the copyright holders, and that's it. So it has to be checked on a case-by-case basis, as far as I remember. And in the bottom of the article, it is mentioned shortly after this report was released, the Trump administration fired the head of the US Copyright Office. Whether this was in the context of this overall paper, I do not know. Nevertheless, it smells a little bit strange. And I checked the link below yesterday, so the report is still online, or at least it was yesterday evening. It's still online. So if you are interested, you can go to this page and download this entire report. Probably it's interesting, probably mainly for lawyers. As I said, I did not read it through. So that are my news I can share. And are there any other news you want to share? No, obviously not.
Yes, perhaps.
Okay, then
sorry,
go ahead.
If, I don't know. Shall we just talk briefly about the pull request? Because from our, I can also share that here. 1 second. So I think Nicola, you can talk on your own. What I did is here this pull request where I uploaded the pictures from this one workshop that we did. So we had in total 4 workshops. The one workshop for the user stories and the blueprints, where you see the pictures in here. The plan is also to use this then also for the Eclipse Apoapsis, and then we potentially can present that next time. The other workshop, I think Oliver will make a summary next time, and here also before Nicola says something about his part, just as an information. So here in the program Markdown, here I shared again, we collected all the provided. Okay, yeah, then I potentially hand over to Nicola. But in the second link, I will write it in the comment. There you can also find now the slides for all the talks. Okay. And with that, I hand over to Nicola.
Thank you. Thank you, Marcel.
Yeah, sure. I can just briefly, hi everyone. I can just briefly update on the PR that I prepared. So this was based on the discussion that we had during the workshop that I moderated, for basically updating the tooling list of the existing OSS tools, or generally the landscape, how it's called. So I've added, I think, 8 or 9 tools that we all agreed on. Generally what we did is we used the capability map and to try to provide information to the list as a tool based on the capability map. So people were reviewing the capability map, although we didn't do the mapping, because I'm not certain whether this is right or wrong, but we discussed during the event with Shane that it's better that probably the tool vendors or maintainers or whoever could actually be the ones to do the mapping, because they would be way more aware of the full capabilities of the tool. And yeah, that's generally it in terms of the actual update. If you'd like, I can also post the PR here, but I think after the review is done, just the data will be available actually within the list itself.
Yeah, I think it will be fine if your pull request, when it's in the repo, then to provide a short email to the mailing list that the material is online. So thank you very much, Nicola.
You're welcome. You're welcome.
Okay. Further news? Obviously not. Then, Philippe, I give the stage to you.
Great. Let me share my screen. We can start. Where? Share. The webcam, share screen, minimize. Always a bit of a.
You have to click on the plus sign, and then you can just.
Yeah. I'm so sorry. I have to take presenter.
Yeah.
Which is a bit of a weird thing. Like I'm not taking anything. Take presenter. And am I actually presenting at the moment?
No, I see the overall.
Oh, share your screen. Okay. No, the big blue button UI always trips me because it has a bit less.
Now, yes.
Great.
Cool.
Great. So I have a very long slide deck. We're gonna go through an excruciating set of slides, and when we run out of time, then I won't do any demonstration. Yep. That was a joke. I have very few slides, and I hope we can go pretty much very quickly to the demo. Right. So I want to talk about the case of code that's been generated by AI. I don't want to talk about the problem because the problem is open, and you were talking about it a bit earlier, Oliver. Lawyers on each side of the ocean, the Atlantic Ocean, have very different opinions on the topic. And the jury is out whether code that's been generated by AI is actually even copyrightable. So there's tons of legal, philosophical, ethical implications for us that do open source development, of course. It's also a set of wonderful tools. Now, I like to think very simply. If I have a zip file that contains a Java file that's been, copied exactly from an Apache project, there's no one will object that this file comes from Apache. And if I have essentially the same file that's been generated by a GenAI powered by an LLM, I tend to think that it's also derived and comes from Apache, even though it has been between code generated by GenAI. I don't think personally that there's much difference between the knowledge compression you have when you zip a file and the knowledge compression you have when you build a large language model, which in some case we'll see in a second is able to spit back verbatim the code that was used to train. So putting that back in context, I like to think to the core what we're doing when we're managing our supply chain is figure out where the code comes from. And one technique is what I call to scan the code, meaning you find things that exist inside. Like, hey, here's a copyright statement, here is a license notice. And I like to think about, on the other side, code matching, where you actually look outside in a precompiled index to see if there's code in your code base that may be similar to code that's been pre-indexed elsewhere. Right? That's the key thing. So just to put that in context, here what we're talking about is code matching. Okay. Let's look now at doing some kind of stuff in ChatGPT. I'm using the free version of ChatGPT. I just go to chatgpt.com and I'm just gonna ask, I'm gonna make that a bit bigger. Generates GS code similar to inherits. I'm just gonna use that. Let's see where it leads us. Okay, it's not exactly what I like. Let's ask a bit the question again. Oops. Okay, it looks a bit better and closer to what I would expect. Now, if you effectively it's funny because you run it twice, you never get the same output, by the way. If you eventually copy this, not the usage example, but the code here, and save that in a file, then what we can do afterwards is run that in scan code. So in scan code, we have this notion of projects, and project, you provide inputs here. That's the file in question. And you run pipelines. So here I run a sequence of pipeline which says, hey, scan this code base. It's a single file, so that's easy. Collect fingerprints and then match that. And what we see here is the results. We have one result, a single file, that's okay. And we actually detected one package. And as it happens, in this case, we detected a version of that package. We can drill down, so it's from this place here. And we have one file that was matched, and we can drill down to the file in question, and we can see the code of that file and see actually what's the match snippet. Now, if we were to go back to the code, it's slightly different version for whatever reason, the version I have here, the version that's generated here, is slightly different, but it's always like that. If I were to go to the original project upstream, I think it's this one, we would find effectively there's a code snippet there that's highly similar. So what's that? That's essentially the gist of it. How did we get there, basically? To get there, you have on the one hand an index of known open source projects. So we keep that in a database called PearlDB, and we collect package metadata together with their files. We fingerprint the files. We run full scans on that. Right now, on this one, there's 21 million. The one I'm using for the demo we have here is a bit bigger. There's in the range of 250,000 package index there for this one. So that's one thing. You want what some folks have called a knowledge base. And on top of that, you want to have a mathematical way to compute these fingerprints so they can then be matched. And there are specific things about the context of AI-generated code, is that it's never exactly the same code that's generated. That's one thing. The second thing is eventually, if you use different model temperatures when you generate the code, you could have code that really looks the same in terms of control flow, but is very different in terms of variable names, class names, and so on. And so there are specific techniques to deal with that, where traditional tools that do code matching, semi-open source tools like ScanOSS. I said semi-open source because their data is private and proprietary, or closed source tool like FOSS-ID or Black Duck Protex. They all use essentially the same mathematical construct for fingerprint, the same algorithm, which is not able to cope with the context of AI generation correctly, because there's too many variations which they won't be able to catch based on what's generated. Now, if we just look back a bit about so quick look at the different tools that do matching. I'm not sure actually OR does exactly matching, but it has interfaces with ScanOSS and maybe FOSS-ID and others. So I did put a cross there. But that gives you a bit of the lay of the land of the different tools that I know exist out there. And if we put that in the context of all the different things we're trying to do with about code, it's really here trying to find the code that exists in the code base. And the further down you go in terms of matching down the stack, you have a higher degree of assurance, of course, also probably more details to review. And so that's a bit of an overview of the project. It's a project that's been in part funded by the European Union, so that's pretty nice. If you're based in Europe, thank you for that. Everything is open code data and how you build this database of a knowledge base. And the steps we've gone through, as I said, here for this demo, indexing a small set of popular JavaScript packages, ask to generate code. And you could say, I'm cheating, I'm asking in my chat to generate code that's similar to an existing project. It may not be something that's used in real life, but the point I'm trying to illustrate there is that you get what you ask for. In many cases, meaning the LLM will be able to reproduce a significant portion of the code that was used to train the model. And whether my prompt is fake or whether it's gonna show up in another context when you do a code completion in some ID that's like Cursor or Windsurf or else, really doesn't matter. It will happen because the code can be reproduced mostly verbatim. Now, if you think about what's the scale there, I've run here larger experiments, which is to generate with ChatGPT the code asking for each of these to generate this based on the Perl. So the prompt was, let's look at what the prompt was. Forgot the exact details of the prompt, but we have documentation for this. Yeah, we've used this prompt here, which says, hey, generate some classic JavaScript code similar to the package identified by this package URL. And I was actually amazed that DLM know about package URL too. And to help with the process and processing the results, says just output code, don't put additional comments or decoration or code examples, and just the code. And we can see some of the example of this generated code, by the way, here. In some case, there's a lot of things that look really boilerplate and not super interesting. It's based on the most popular package, and in JavaScript, popular means sometimes very short. Anyway, I have this data set of about 100 packages, and then I run this scan code scan, where I did scan each of these files, fingerprinted it, and then matched them. And what you see as a result is, out of 100 files, I have matched about 30 of them to existing packages. And when you actually drill down through each of these, the matches are unfortunately positive. Some of them could be questionable, not so much because they're not matched, but whether the code that was matched is actually copyrightable. Let's look at maybe this one here. And look at the viewer to see the match section. There's maybe a few bugs. You know, the code is fairly fresh. I don't know why we matched that. And it could be that this is bullshit code that's not even copyrightable. So I'm not claiming it's perfect, far from that. The point is, you have code that was matched verbatim to an existing open source project in the code here that was generated. We're not able, by the way, right now yet to show results side by side like a diff. We just can highlight the portion of the code you analyze as being matched. But that's the essence of it. There's it's a new capability. There's, as I said, so some issues. We have code that may not be entirely relevant. There's case also, which is really the problem with JavaScript. Here is a JavaScript package, and of course that's the problem with the JavaScript ecosystem, is that you have packages that should not exist in the first place. This should be code that you copy, shouldn't be code that you package. It's a liability, it's a left pad-like kind of package. And unfortunately, these packages are quite popular. So they were part of the test set because if you look about who depends on these packages, there's a large number of these. So that's pretty much it in terms of showcasing some of the capabilities. I don't know if you guys have questions, and then we can talk a bit about FOSDEM afterwards. There would be a lot more to say and discuss about the details, how the matching takes place, and so on. But it's reaching a stage where this is actually usable. The other interesting thing here is when we do this matching here, we're actually not, we're sending that to a backend server that has access to the database. But the important thing is it's something that takes place in steps. So it's not only looking at snippets, but it's trying to find whole code trees, exact match, approximate match to file, to trees. And then for things that were not matched, it tries to find code fragments and eventually modify code fragments. So in many cases, you may not get code fragments or snippet-like match at all. You may get larger matches to bigger aggregates. Questions?
I think there's a question from Julian in the chat, so I read it. I understand that you have developed a snippet hashing algorithm, but the database is not yet built, right?
There's a database that's built.
Okay.
We have multiple databases. We're working on a model to actually effectively distribute the data in the open so it can be used on premise without having any dependence on the thing. And it's difficult because this is a lot of data, as you probably know.
Yes.
And so there's a separate project called Federated Code to work to share the data, including the fingerprints, the scans results, the scan details, vulnerabilities, in a way that's easy to replicate in many different places and easy to share without having systematically to download dumps, which could be 10 or hundreds of gigabytes. Right now, that's the problem, is the data would be too big to share. And this project Federated Code is a solution so the data can be effectively shared in small increments efficiently for on-premise usage.
There's another question, still by Julian. Is your idea to construct a large database or to provide solutions creating ad hoc databases with only the code used to train an LLM?
You can do both. You can do both. There's this project called Big Code. Big Code. Yeah, at Hugging Face. So Hugging Face worked originally with the folks from Software Heritage to isolate a subset of the code. They scanned that with scan code to ensure that they would hopefully only include permissively licensed non-proprietary code in their index. So that could be a database there. The thing about the algorithm is that it's designed in such a way that you are able to match code that's never been indexed. Where if you use the classical approach, which is to break a file into fragments with a heuristic, which we use also, but we use a different heuristic. But then you essentially take a checksum on each of the fragments. You can only match the fragment if it's been indexed. So what you see is that you have forever race forward to have an ever larger index, because if you don't grow your index, you won't be able to match this code fragment, even if they have been mildly modified. Where the approach we have is that we're able to match within reasons, within some reasonable distance, code that's not at all similar to any of the code, well, which is somewhat similar to some of the code that was indexed, but it's not code that was ever indexed. So in that sense, that's really important, because we're able to have a smaller index and essentially similar results. That's a claim. I'll have to verify it, and we'll verify it by running actual benchmarks. The other thing is there's a project called Code Commands that we're working with the folks from Software Heritage. And part of it is to run scan code at scale on the whole 20 or 30 billion files of the Software Heritage archives in terms of source code. And we'll also run the fingerprint. So we'll have the data set of fingerprints on all the content of the Software Heritage archive available pretty soon also.
Mhm.
And so the goal is also, once again, to have that made available as part of the Software Heritage archive, and also distributed through federated code. So it's easy to replicate, but it's also easy to create, if need be, topical focused index. Because if everything I'm using is only Java and JavaScript, I don't care for Rust and Helm and any other languages. Or if I care for them, it's really very secondary. So I can have multi-level indexes and focus index where I may replicate only the thing I care for first. And conceptually, it doesn't make sense, for instance, to try to match C code to Java code.
Yeah.
It's possible that you can have actually C code that's been derived from Java code, or the other way around. I've seen one case in scanning hundreds of billions of lines of code and hundreds of billions of files, where you had a case of JavaScript code that was ported from C, and ported in a sense like lightly rewritten, kept with comment and everything. So it happens, but it's a very rare event, meaning you can have pretty good mileage by not scanning everything against everything, but focusing on the tech stack you use and having smaller indexes. Also, small index, it means less false positive, faster scans, and everything else.
Mhm. I see. Cool. There's another question still by Julian. Question on the algorithm you use for fingerprinting snippets. Can you provide the URL to the code?
Yes. So all the code is online, and you can check the entry point of the project. So that's the project itself is here. I can paste that somewhere in the chat. Where's the chat? Here. Chat. And then the code itself is many different places. It's scattered between ScanCode.io and PearlDB as main repositories. But you'll be able to see some of the pointers there, so you can check out that, and you can check out match code toolkit here. Is one of the libraries we use, and you can check out also ScanCode.io. It exercises a lot of the stack we have in about code, so you need to look at a lot of this stuff. But the entry point here again is going to be the documentation for specifically this focus on the code to explain the program and the project, and also you have pointers to the different design on the fingerprints indexing, and I'm assuming it's probably the kind of thing that you're quite interested to buy and that you can check.
Mm-hmm. Cool. And the last question from Julian is, last we have some improvements to suggest to your comparison chart with ScanOSS. Can we contribute, or where can we contribute to it?
I'm not sure I understand the question.
So obviously, I think Julian has something.
Hello.
Yeah.
Sorry, I have the microphone. Yeah, thanks, Philippe, for the presentation. We had some suggestions to improve your comparison chart where you compare ScanOSS. So is that something that it's open and that we can contribute to it?
You know, Philippe, the slide you have shown.
Yeah.
Sorry, I was muted. So you mean the slide I was presenting?
Yeah, there's a comparison chart with ScanOSS, where it says that we don't do scanning.
Yes, this one. This one.
Yeah, like we don't do scanning. I mean, I don't want to get into the discussion here, but is this something, since it's a CC by SA? I mean, is this document public that we can contribute to it, or I can give you feedback and we can discuss it?
Send an email and update that, definitely.
Okay, good. We'll do that.
If you don't mind to share an email. The document is public in the sense that I'm sharing it now.
Yeah.
I'll share the slide with Oliver afterwards if we can have them available to everyone. But
okay.
It's something that I've used this slide in a few other places, so it might not be guaranteed to be 100% up to date. You see, yeah. So we don't even have matching, and well, actually it's match code. It's different tools, but yeah. But if it's incorrect, please drop me a note and we'll update that.
Thank you.
Cool. Are there further questions in regard to this presentation to Philip? Obviously not. Then thank you, Philip, very much for this presentation. I found it very interesting. And as you said, you will share the slides with me. And now we go immediately to FOSDEM.
Yes. So it's going to be faster and simpler because I just have a single slide there. Well, oops, there you go. So a bit of feedback on FOSDEM, and not feedback on FeedDem. So some of the things that came out of the discussion there, and there's more to it, by the way. There's a report that was written by Adam Herzog, and I don't know where he stands there to have it ready to share, but there were extensive notes. The thing is that there's two issues that came out to me and that I've been discussing, or people are discussing it over and over again, is the problem of interoperability across tools and ecosystem. The fact that even though we've been building tools, we are very often rebuilding the same tools over and over again. Sometimes just for spite, because we want to write these in a separate language. So I don't think this is avoidable. But if we had better ways to exchange data between tools, that would be best. And I wished, and I wish, that we could use SBOMs for that. But SBOMs were designed to convey business information. It may not be exactly the information we want to exchange between tools, which may need more details. But I think if there's one thing we could do, and one thing we've discussed there, is if we can share and maybe standardize on SBOM and trying to enhance the SBOM standards so they can fit our needs to exchange data between tools. That would be very powerful. And I would be ready to have, I would not say subpar, but less efficient exchange of data between tools if they're mediated through a standard format, even if the format is quirky and has a few problems. That's always better than having one standard per tool. The other thing that was discussed also is issues around SBOM tooling and the fact that we don't have good ways to validate or visualize or trust SBOMs that are shared. It's a bigger problem, but two simple phenomena, two simple visible problems is two things. First, well, two anecdotes. One reported to me by a guy working in a large company that they do devices, and is working on the open source program office, ensuring that devices that go out of the door have proper inventory of known open source packages that are there, and license and security issues eventually are dealt with before the device is shipped. And there was this device product team brought up and says, hey, we run our tool. It's wonderful. There's only 3 open source packages. This was an embedded device with a full Linux stack, kernel, user land, and a bunch of entertainment systems. So a real user land with a UI and everything on it. And of course, there was much more than 3 packages, but the tool said they were using, which was a commercial tool that's been out there, one of the earliest in the space, which I will not name, that there's 3 packages. Now, the firmware in question was encrypted, and once you would decrypt the firmware, that would be a smorgasbord of packages with several hundred packages with proprietary code, open source code of license which were not acceptable for the policy of that company, vulnerable code, tens of packages with serious critical vulnerabilities. So it's hard to trust the tool. Second point, 2 tools will give different results. It's another case where a user of scan code had shared an SBOM built and something which had been carefully reviewed and vetted with one of their customers. And then the customers run their own tool on the binaries they received from that vendor. And they came back and says, oh, but your SBOM is wrong. We've detected different packages. You're wrong. And so imagine what's happening there. You have 2 large corporations. So the tech team eventually went to procurement, which went to the sales team of the vendor, which went to talk to the pre-sales team, that went to talk to development team, that went to talk to the legal team, spinning their wheels all the way, and then you have like days and days of work eventually to come out with something which was a non-issue. One of the two tools were wrong. In this case, luckily, scan code was right, or the SBOM that was produced was correct on the vendor side, but it could have been the other way around. And the difficulty is that's going to happen a lot. Different tools, some of them ignore code and won't give you the correct SBOM, or different tools on the same topic will give you different results. That's a big problem. Last is the fact that we all we've discussed that the year before and the year before again, is we all rescan the same package over and over again. I was at a small open source event the last couple of days in Paris, and there was a guy that said that so they have an open source product that embeds a lot of open source, and one of them is zlib or zlib or zlib. I never know how to pronounce it. If you scan zlib, you'll notice that there's a contribution directory with a lot of support for different language, for Ada, for Pascal, and else. And they had a customer that came to them and says, hey, you know, using zlib, it has these critical vulnerabilities, blah, 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 blah. Please fix that. And it happened, it was a vulnerability in Ada contributed code, which is not part of the deployed binary because they don't use Ada, they use C. And so the problem we have is that we have, in this case, coarse-grained data. We probably each know collectively here or individually, we know that, yes, this directory in zlib is 99.99% of the time not a problem. But we're not sharing this data. So being able to share this review, this messaging creation, this research we do, I think is something that came out as really important. Being able to share, avoiding rescanning, redoing the same research over and over again. And also, because it's difficult, coming back to the first problem, because it's difficult to figure out if two tools are equal in terms of their capabilities, we cannot trust vendors, and you cannot trust open source developers also. At least you can verify, but you cannot trust commercial vendors. The only thing we can trust is given an input, we expect this output. And I think there's a lot of things that was started by Marcel on the digital dummies. But I think being able to extend that to have repositories on containers, on reference application, which would be real life open source application that are accessible to everyone, that we've collectively created in terms of what is the set of package they have exactly, maybe in source and in the deployed binaries, so that when you select a tool, you want to make sure that your tool is as good as possible at matching the expected benchmark we've collectively agreed on. So to me, these were the key thing. Knowledge sharing, again, that's been a topic over and over again. I hope that what we're trying to do with federated code may help. It's several months out to be in a fully usable state for sharing scans. It starts to be usable to share vulnerabilities, at least. Mm. And the way I would see things going forward in the future, at least on my side, is that we never scan twice the same package version with the same tool. And that we can share the scan results from eventually different tools. And then in some cases come with very different conclusion about origin license, but in most cases we may agree and come with something. And in the end, the important thing that would be left to each of the users would be to apply a policy. Mm-hmm. And my policy may be I love GPL, and your policy is that you hate MIT. And that we can't share, but at least we can share the facts, so each of us can apply policies on top. Yeah.
Cool. Thank you very much for the recap of the Frost and Fringe event. And by the way, again, a big thank you to you and Adam and all the involved persons to make this happen. I found it really interesting, although it was a really, how should I say, it was an exhaustive day, yeah? Because so many tools, so many persons introducing their tools, and this was really, really good. I love this event, Philip. So
yeah, no, and I think we should keep it on a single day, single track. Personally,
yes,
there's been people that says, "Oh, what about making it 2 days? What about splitting?" And I think if we start splitting, we may lose a lot about the having a single voice and in some case a better common understanding about the things we discuss about. I said, I was in this small open source event in Paris the last 2 days, and there were workshops, breakout sessions. There were 4 at a time, 2 times a day for 2 days, and I couldn't be in 8 places at the same time, and I hated that.
Yeah.
And I wish I could have been going to the 8 workshops at the same time, but it was not possible.
Yeah, and this adds to fragmentation, yeah, because if persons in one workshop do not get the information of the other workshop, and so on and so on.
Yeah.
We have 3 minutes left. So I would suggest, to be honest, that we conclude this call and then that we, in the next Wednesday meeting, which is the first Wednesday meeting in the new month, then we start here with for the entire meeting with the work on the capability model in order to get this into shape, because I think in 3 minutes it does not make sense, or to touch on a new topic. Obviously not. Then thank you again, Philip. It was really interesting. And then I conclude the call, and thank you for all your participation and for your questions and the answers, and I wish you a nice evening.
Hey, thank you everyone. A wonderful day, a wonderful night.
Thank you.
Thank you. Bye.